In this video, we will return again to the CombiRx infection subset, picking up from the last video where we tested 2 proportions to now testing multiple proportions. If you recall, in the last video, we excluded row 129 for the person that was unsure about mononucleosis. This row is still selected, and we want to add it back in, so we'll go to the rows menu and click Exclude Unexclude again. And now you can see that this row is included again, and we do not have any excluded rows associated with this data anymore. So in order to test multiple proportions, so an R by S table with multiple rows and multiple columns, we want to actually look at measles by age group. So in the first video, remember, we classified our age groups and labeled them. And in this, we want to compare it to measles, yes or no. So let's do a quick distribution on our age groups and in our measles. And we can see that we have 344 responses on age group, with 15% being 18 to 29 years old, 32% 30 to 39, 29% 40 to 49, and 24% 50 to 60 years of age. We have 43% reporting that they were sure they had been exposed or had measles, and 55% that they had not, and 2% or 7 people reporting that they were unsure. It would be important to note the 7 people, or the 2.0% unsure, but also to note that to test the proportion between sure and unsure, we're going to exclude those that were unsure. So if we wanted to test yes or no, we need to exclude those that were unsure. So I selected them there, and I'm going to say row exclude. And you can see now here that we have 7 rows excluded in our data table on the lower left-hand rows menu. So I will back out of this, press close. And now I want to make my measles have meaningful values for my output. So I'm going to select measles. And go to column information. And in column information, I then want to do value labels. 1 for yes, add. 2 for no, add. Press OK. And you'll notice that my 3 here is left at 3, but that's okay because those are excluded. I could add a 3 for unsure if I wanted to, but I'm only going to be working with the yeses and nos. So for right now, for brevity, we'll leave it at yes and no. To test age group by measles presence or absence, it's fit Y by X. Age group at baseline as my X. Measles as my Y. And press OK. And you can see here I get my mosaic plot. Remember, the far right side is the overall proportion of yes and the overall proportion of no. And then each of these shows the proportion yes and the proportion no for each of the age groups. It's an interesting stair-step pattern here, which means we are seeing some variability or departure from the overall proportion. Of course, our question or our null hypothesis will be is if these red proportions are statistically significantly different from one another, or if there's at least one difference. So I'm going to close the mosaic plot because, again, it's not useful for presentation outside of JUMP. And I'm going to take a look at my 4 by 2 table. I have my age groups at baseline and my measles yes or no. I'd want to report a meaningful statistic, and that is most likely going to be the proportion of those within each age group that have reported measles. So of 18 to 29-year-olds, I will report this row proportion of 5.9. 30 to 39-year-olds, I will report the row proportion of 18.4. 40 to 49-year-olds, I'll report the proportion of 55.2. And for 50 to 60-year-olds, I will report the proportion of 88.9. Now, this is quite a demonstration actually about the prevalence of measles and age group and vaccinations. There was a certain time when most people got measles until a vaccine that worked was developed. And you can see those that are younger now are reporting, or at least we're observing, a lower proportion of those with measles than those who were older and the vaccine wasn't readily available or in fact available at all. Our question here is simply, is the proportion of 5.9 equal to 18.4 equal to 55.2 equal to 88.9? That's our question. Do we have an equal proportion or percentage by age group who've reported having had the measles? That's our null. Our alternative is that there is at least one difference. Our likelihood ratio, Pearson chi-square, gives us a p-value of less than 0.0001. So compared to actually all equal proportions, comparing that to an alpha of 0.05, we would reject our null hypothesis of equal proportions and choose to believe that we have a difference in proportions of those reporting measles by age group. And you could refer back to the table that had the proportions in it. Now, you may want to know, where is the age that we're finding the difference? So we can go back here to the contingency table, and I'm going to take our total percent and our column percent out. One thing we didn't check here or in prior videos was the expected cell sizes, but you'll also notice in the prior videos that we didn't get a warning from JUMP about our expectations that would be below the test results. We can still check it here, ask for expecteds, and we'll notice that all of our expected values are greater than 5, so that's not an issue. I'll remove the expecteds. And what I actually want to ask for is the cell chi-square value. Now remember, chi-square values greater than about a 2 when we're doing a 1 degree of freedom test are interesting to us. And so we can take a look here and see that we have very large cell chi-square values for everywhere but the 40 to 49-year-olds. We had an expectation that our overall proportion of those yes was 43.9%. 43.9% measles. The 40 to 49-year-olds were about 12% larger, absolute larger than expected overall. And so therefore our chi-square values aren't that huge because it's relatively close. It's not very close, but it's relatively close. What we can see here is that our 18 to 29, our 30 to 39, and our 50 to 60 all have large cell chi-square values. And therefore, we're actually seeing a difference in overall or expected proportions from our observed. And so what we can see here, or what we could conclude here, is that actually we have probably likely 4 different proportions and that they are different by age group. And that would be your overall summary, that we have a difference in proportion of those reporting a history of measles by age group, and then report the individual proportions that you saw. Now, a quick loop back here. If our expected values had shown us that we needed an exact test, you could ask in the large red, in the top red menu, for a Fisher's exact test, and JUMP would produce that for you if you had violated the sample sizes. Here we did not, so we would report the likelihood ratio test, we would report the individual proportions, and we would report that we had a difference in proportions of measles.